Let's begin. Today is August 10th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 2, 5, 10, 17, 19, and 22. And the puzzle uses the green verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. So criteria card A looks at our first digit, the triangle digit, and compares it to the number 3. So should the value of triangle be less than 3, should it be equal to 3, or should triangle be greater than 3? Criteria card B again looks at our triangle digit, but this time it'll let us know whether its value is an even digit or an odd digit. Criteria card C will look at the 3-digit solution and will let us know how many of those digits are 4. Are there no 4s? A single 4, perhaps 2, maybe even all 3 are 4. Criteria card D again looks at our 3-digit solution, but this time will let us know how many evens there are. Are there no evens? Is there a single even, perhaps 2, maybe even all 3 are even? Criteria card E will take a look at the first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card F will look at the 3-digit solution, triangle, square, circle, and let us know something about the ordering of the digits. So should the digits be in an ascending order, meaning that they're increasing, as in the example 135, or should they be in a descending order, or decreasing, as in the example 421, or could it be that they have no order? Let's take a look at the example 231. Notice that it goes from 2 to 3, so it increases, but then it goes from 3 to 1 and then decreases. So it's that shift that is one way to define that it has no order. We've also seen in other puzzle solutions where if 2 digits are consecutive digits are equal, the fact that it neither increases nor decreases is another way you could define that the solution has no order. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 6 criteria cards. And we're going to start off with an initial proposal of 314. So the first thing I want to find out is, I want to find out if that first digit triangle is even or odd. So let me go ahead and test criteria card B. Okay, so the Turing Machine does not approve of my choice of an odd 3. Since it's not odd, the Turing Machine is telling me that it's an even digit. So let me go ahead and type that up in my notes for section B. That triangle is an even digit. And since it is even, well, it can't be odd, so let's go ahead and cross out 1, 3, and 5. Okay, so at least now we know that for criteria card A, it's either going to be less than 3 or greater than 3. So it's a 50-50. But I think I'm going to wait until the next round. I think I'm going to go ahead and test maybe criteria card E. Typically, if it's an even, it's not a guarantee, but it could be that the sum is equal to 6. I don't have that, but it may just be worth it to go ahead and test that. So let's go ahead and test criteria card E. Okay, so yeah, it's my first 2 digits, 3 and 1, add up to 4, which is less than 6, but the Turing Machine does not approve that. So basically, the sum is either equal to 6 or greater than 6. So let me go ahead and put that in my notes for section E. That triangle plus square is either equal to or greater than 6. Okay, and I think because let's see, I think since the sum can be 6, can we eliminate, actually, yeah, I think, yeah, we can eliminate, the 1 for square, because if you were to add 1 and either 2 or 4, that's all smaller than 6. So yeah, surprisingly, we could eliminate 1 for square. Now we can't do the same for 4 or even 2, because yeah, 2 plus 4 and 2 plus 5 are still viable possibilities. So, and of course, yeah, 4 and 2 is 6, and anything greater obviously is going to be bigger. So yeah, it seems like we can only cross out square, the 1 for square. Okay, so we do have a couple of other criteria cards here. Let's see. Either even or 4. I think we can cross out the possibility of there being 3 4s, because if we knew there were 3 4s, we would know that all of them are even, and that would mean that this card would be irrelevant. So we know that can't have 3 4s. It could have 2, 1, or none. Just don't know. What else? Let's see. I do have 2 odds to a single even. I already know that there's at least 1 even. So we know that it's not 0. It could be all 3, or 1 or 2. Just don't know. You know what? Let's go ahead and test criteria card A. Let's just figure out what is triangle. Maybe that'll help us figure out what square is in the next round. So let's go ahead and test criteria card A. Well, oh, never mind. That would not be helpful because I have a 3. So I was going to get it wrong anyway. Good catch. Okay, so since that's the case, how should we play this even versus 4? I think it's best to know if there are evens rather than 4s, because 4 is so specific. I don't know. And obviously it can't be, I can't imagine it being the same number. I guess it's possible. You know, you have 2 4s, okay, you only have 2 evens. Maybe that's the case. Like I said, but I don't think you could have 3 4s, because that would tell you that you have 3 evens for sure. So yeah, let's go ahead and test the number of evens, criteria card D. Okay, so of course we know it can't be none because we already have 1, and I have a single even, and that's not enough. So it's either 2 evens or 3 evens. So let's go ahead and type that up in our notes for section D. So there are either 2 or 3 evens. Yeah, since can be none and 1 failed, the only possibilities are 2 or 3. Okay, well that does it for this round. We've already completed our 3 Turing tests, and we're going into the phase where we'll be discussing how to construct a good second round proposal. So notice that, of course, you know, luckily we didn't test A, criteria card A, because we know that there is at least a 2 or 4 there, and we didn't test how many 4s. Obviously, it's still an outstanding issue of how many evens there are, or whether the sum is equal to 6 or greater than 6. And of course, there's the ordering aspect. Okay, so is there anything? So this is, let's see, I'm trying to think of possibilities since we do have this ordering. Just because we have 3 evens, if there are 3 evens, I think there can't be 3 evens, because if there were, let's consider the possibilities. The first 2 are, say, the same, as in, say, 2, 2, 4. That's no order. And if you were to, say, have the last, or the first and the last be the same, then 2, 4, 2 would have no order. So yeah, so I think, wow, this is very interesting. I never thought about this. I think we can conclude that there can't be 3 evens. There has to be 2. Because if you have all 3, all cases, again, I only talked about the double 2s, but vice versa, if it's double 4s, it would work the same way. Wow, very interesting if that turns out to be true. That is a pretty amazing thought experiment, that if you had 3 evens, that would automatically mean that there's no order. Okay, so let's go with the premise that there are 2 evens. The question is it 2, 4, adding them up in triangle and square, but then what would that look like? So it was 2, 4. I don't think it could be 1 or 3, because how would you distinguish? So it would have to be 2, 4, 5, or if it's the other way around, 4, 2, it would have to be 1, or descending. Very interesting. And it doesn't have to be, right? That's if it's 6. What if square happens to be odd? It's not a 6, and therefore the sum would be greater than 6. So that would be interesting. It could be, say, a 2, 5, because that's the only possibility, 2, 5, and then of course 4 for the other even, or it could be even 2, 5, 2. Well, that's true. How would that work? Both 2 and 4 are less than 5. I guess there has to be a 4 using criteria card C. So yeah, if triangle is less than 3, that forces square to be 5 for a sum that's greater than 6, and then there's a single 4. Well, that sounds like a great second round proposal. So let's do that. 2, 5, 4. Okay, so does that mean we have to test everything? I think we've deduced that there are 2 evens. Yeah, maybe if triangle is less than 3, again, we're deducing that there's 2 evens. Then how would you pick 1, 3, or 5? Well, I guess the ordering could decide that. Okay, well, let's go ahead and test. Let's see. What about if the sum is greater than? 4 would have lots of possibilities. Could you say that 4 would have too many redundant? Well, let's just go ahead and test criteria card A. Wow, it is not 2. Okay, that's interesting. Okay, so So basically, yeah, we're deducing that triangle is 4, it's greater than 3. So let's go ahead and type that up. So we're going to deduce that triangle is greater than 3. And therefore it is a 4. Very interesting indeed. So let's go ahead and cross out the 2. Okay, well, now I'm intrigued about, could this be 6? There are lots of possibilities for not 6. Very interesting indeed. Well, let's see, we haven't tested, yeah, the number 4s or the ordering. Well, we do have a single 4, and it's already there. So we know it can't be 0. And I don't think it can be 3. So there's either 1 or 2. I just don't want to... I don't want to go to a 3rd round. So can I do it in just 2 rounds? If I know it's not 6, then how do we choose? Then we kind of lose an opportunity. Yeah, let's go ahead and test criteria card C to see how many 4s there are. Okay, so there is a single 4. So that means that square can't be 4. And neither can circle. Okay. And we did sort of deduce that there had to be only 2 evens, not 3, because of the ordering. So it could be 6. So I guess it could be 4, 2. But then how do you distinguish? Yeah, I may have to go to a third round. So we have either a 2 here or 2 here. If I choose, yeah, let's go ahead. So I have no order right now. It can't be ascending. We know that much because there's just no room for it. So if it is no order, I guess it could be 4, 5, 2 or 4, 2, 5. So yeah, well, the sum would do it, but what about the order? Well, okay, can't be ascending, can it be descending? With 2 evens, it could either be 4, 2, 1 or 4, 3, 2. So yeah, it does seem like we're gonna have to I think I'm gonna test criteria card E again. Okay, so the sum is greater than 6. Since I have a 2 and a 5, that sums up to 7. So that means it's not equal to 6. So that means that it's not equal. In fact, it is greater than. And so that means we know it can't be, square cannot be a 2, because that would give us a sum of 6. And so that means that circle has to be the 2. Again, we sort of deduced that there are 2 evens. So I'm hoping that that deduction proves true. Okay. So then, yeah, so is it no order or is it descending? We're going to have to do one more round. So let's just pick 452. 452. Okay. And then we'll test F. Yes, it is no order. So let's see, what did I, oh, so for C, there is a single 4-digit, and for F, we'll say there is no order, and so that would mean that it would have to be 5. Okay, so if all my deductions turned out true, it looks like a good solution, 452. So let's type it up. Okay, computer's a little bit lagging. All right, let's go verify 452 as a solution. Four, 5, 2. Okay, fantastic. Well, let's see how we did against the Turing machine, because we did go 3 rounds and did 7 tests. We'll see how we did. So we did BDE, and then in the first round, and then ACE the second, and then F on the final 3rd round. So BDE, and those were all incorrect. And then we did ACE, A was wrong, but C and E were correct. And then finally, 3rd round, F was correct. How do we do? Okay, so we beat it by 1. So I was somewhat concerned, but I think it worked out. I really do think somehow that deduction, and I'm hoping it's still a valid argument, that if you have 3 evens, that would make this ordering irrelevant. So then we deduce that there had to be only 2 evens, and it worked out that way. But again, I don't know if that argument, it does sound plausible that it's correct. Okay, well, very interesting puzzle nonetheless. Challenged all of us to the 3rd round, but it was a success. So it was a great solve. Well, what are your thoughts? Add them to the comments. If you liked the video, give it a thumbs up. And if you don't want to miss out on any videos, make sure to hit subscribe to be notified. Well, until next time, have a great one.